Hi everyone, my name is Kevin Limtow. I'll be describing my Proj01 Morse code LED system. At a very high level, the system is a combination of hardware and embedded software necessary to translate user-typed strings into sequences of the Morse code that will be displayed over an LED. The goal is to create an embedded software application that performs this functionality on Arduino. And I hope you're seeing my video that is taking a live feed of the Arduino connected to a breadboard with an LED attached. I might be able to get a zoomed in picture as we go. But first, I'll talk about the requirements of this project, the design of the project, both hardware and software, and the implementation, or rather just code base for this project. So as we mentioned, or as I mentioned, the system is a pretty simple one, a combination of that hardware and software to take strings and convert them into Morse code displayed over LED. So the stipulated requirements, these were captured as part of the project prompt. And these are nothing new, but the application should be developed using C or C++. I'll describe a little bit of the software implementation a little bit later on in this video. It's going to execute on our Arduino. That's what you see, hopefully, in the video. It's going to take in a user-type string, such as hello world, and it's going to display that user-type string in Morse code LED, and that's what I'll have in hardware setup. The application is going to implement all of the Morse code letters. I've also included extra functionality for Morse code numbers as well. I'll describe how I did that. And the application shall use a round-robin design, and it will be developed, or may be developed rather, using Arduino Sketch, AVRDude, or some other IDE. In my case, I decided to use Visual Studio Code with the Platform.io extension. Some derived requirements. I actually did spend a little bit of time developing this using the Arduino IDE, and I'm actually still going to use the Arduino IDE, mostly just as a serial monitor, because it allows me to more easily communicate with the Arduino and send strings down over to it for it to translate. I'm using an Arduino Uno. Actually, I believe this is actually a knockoff Arduino Uno that I purchased. It came as part of a kit. It's a Elegoo Uno R3, but for the most part, it behaves like an Arduino Uno. And when you connect it to your laptop with Arduino IDE, it registers. I'm going to interact with the device or the system through the serial monitor, through a serial monitor. The application itself over the serial monitor is going to request a string from myself, and I will input a string, and the application is going to convert that user type string into Morse code. I have some requirements for how to translate the string into Morse code in the way of an LED flashing. I believe there are some standards on how Morse code operates. We call dots out as some time base, and dashes are some multiplier of the time base for dots. Spaces between characters, spaces between dots or dashes of a Morse code character, and spaces between words are all actually fairly well standardized in Morse code and are always some multiplier of the time base that is given to a dot. Application shall print characters to the serial monitor as the LED is outputting them, just so I can use it as a debugging tool and observe that the application is working as intended. The application shall inform the user when user type strings have been fully displayed, so that way I, as the user, know when the Morse code has completed and the application is ready to accept another string from me. And we need to be able to use a sentinel character to exit the round robin loop. I've decided to just use a / for that. It could have been. Moving on into the design of the system, I'll start with software here and zoom in on this activity diagram that you see here. It's a very simple, straightforward software design. There is a user thread and, of course, the application thread. From the user's perspective, I'm doing very little. I'm just connecting my Arduino to a laptop via USB. I'm going to open up a serial monitor application. In this case, I'm using the Arduino IDE. And when the application is ready, I'm going to be sending strings to and from that application, or to that application, rather. The application has the much harder job. When it first starts up, it's going to print out an intro message. It's going to request an input string from myself. And it's, after that, going to initiate the round-robin loop. And at that point, it is checking the serial line to see if a string has been sent into the application. There's a couple checks that I'm actually doing in the design itself, which is one, check for the sentinel character to see if we need to go ahead and stop the application. I also added some functionality to check for the validity of a string, just because my particular Morse code program doesn't take in special characters, exclamation points, @ sign, pound sign. I didn't want to have to try to figure out how to implement those in Morse code, because I actually don't know if there's a standard Morse code for special characters. I decided to limit this application really to just alphanumeric characters. So that's my validity check that I have in the software design. After a string is input, and if it is a valid string, it's going to tease apart that string into individual characters, translate each character to Morse code, print that character through the serial communication line, through to the serial monitor. It's going to flash that LED the requisite number of times, and it's going to loop that until it parses that entire string and displays the full word in Morse code. At that point, it's going to send a message complete and request a new input string from the user, myself. So that's basically the software design. I have it in text, of course, but as we scroll on through, I have the hardware design, which is very straightforward. You're seeing the Arduino Uno here instead of the Elegoo Uno R3, but very, very similar platforms. I have a breadboard set up with a simple red LED and a resistor. I have the red LED connected to digital output 5 or pin 5 of the digital lines on the Arduino. A simple 1K resistor, just making sure that I don't blow out the LED. So the digital output current of the Arduino Uno is actually, well, I think it's limited to something like 40 milliamps. So it's not really a danger for the LED. But I think good practice suggests that you should have a light resistor going to the either pin of the LED to prevent a lot of current going through it. So I just have 1K resistor there. And that's basically the hardware design. And so we'll get into the implementation quickly. The implementation, as you can see here, I just instantiate everything in Visual Studio Code here. The first part of the code, this is just because I'm not in the Arduino IDE. I need to include the Arduino.h library, or framework, and that's just a necessary aspect of running or developing this code in Platform IO, which is an extension that you can add to Visual Studio Code. I have some debugging tools I gave myself. I've just commented these out. I have a number of variables that I use to define things like the number of milliseconds associated with how long a dot will take to display, how long a dash will take to display, how long to wait between individual Morse code symbols, and all of these are parameterized at the top of my code. So if I decide I want my time base to be a little bit longer or shorter, I can update my number of milliseconds for the dot length variable, and everything should propagate onto the code. I've created a string here, which is just translate to Morse code. That may be more interesting to go through, so I'll go ahead and jump to the bottom of my code here where I've actually instantiated that function. The function is very simple. It's just a switch case structure where I take in a character. I make sure that that character is shifted to uppercase, just so I don't have to deal with lowercase and uppercase symbols. So that's what the code base is doing here. It's converting everything to uppercase. And so that way I can basically run through all of these different cases and return a simple string that is the representation of that alphanumeric character in dashes or dots per standard Morse code. And so it'll return this string of dashes and dots. And once it has that, it'll go through my parser, which I'll describe in just a moment. But let me take a step back. That's the function to translate individual characters into Morse code. But if we go back to the beginning here in my setup loop, or sorry, not setup loop, but in my setup structure here, as I said in the software design part of this video, I had made sure to have a welcome message presented to users over the serial communication port, which I had opened here and set a baud rate of 9600. The welcome message is fairly simple, and it also, the setup requests that the user enter an alphanumeric string or a sentinel character to end the program. Then we get into this round robin loop that you see here. This is just the void loop that's standard for programming in Arduino. It is checking to see if anything is available over serial. And so if there is, if serial.available is greater than 0, it's going to read in whatever string was input and pull that into an input variable that you see here. It's going to check the length. So one interesting thing that I found as I was testing and debugging this code was that every time I sent in a message over my serial monitor, it was appending end of line character, and the end of line character messed up my validity checks. So what I'm actually doing here is I'm just dropping the very last character of my serial.read string function, so that way my end of line character doesn't break my code. So that's just an intricacy that I had to include here and have a comment describing why I had to do that. I have a check for sentinel character, in this case, again, that / and I have a goodbye message, very simple. I have a check for input validity, so I just go through each character of the input string and decide if it is alphanumeric. That's this is al num function. That's, I believe, just native. I didn't have to load any specific packages or libraries in order to use that function. I also had to do a check to make sure that even though spaces are not alphanumeric, I didn't want spaces in my string to break the validity check. So if I wanted to have hello world as my input string, I could, if that would still pass my validity check, even though there is a space between hello and world. That is an exception that I have for my validity check. And then finally, I have my actual set of code here to take the Morse code and translate that into my LED display here. So the code is fairly straightforward, just a for loop structure. At the beginning of the for loop, I'm taking in the input string, I'm taking the first character of it, I'm printing that out to the serial monitor just so I know it's progressing. If there is a space in the word, I'm giving it a longer period of time where the LED is off, just to represent any spaces in the input string. You'll see that translate to Morse function once again here in the code. And after I get that Morse code string, I have another for loop that parses that Morse code string and decides if it's a dot, I'm going to turn on the LED for the appropriate amount of time for a dot, and then I'm going to turn it off for the period of time associated with the time base between symbols in the Morse code. And similarly, if it's a dash, turn on the LED for slightly longer, and that's the dash length. And then at the very end of displaying the Morse code string, I have a delay again, which is the space between characters of the overall string. And then here at the very end, I just have to make sure I clear out my input string variable. Otherwise, this loop is going to go on and keep spitting out the exact same Morse code string over and over again, which we obviously don't want. We want the application to stop and request a new string from the user, and that's what you have here. So I'll go ahead and load this. For those not familiar with Platform IO, just at the bottom here, there's a build and upload button that I can press, and I'm already hooked up to the appropriate COM port, as you can see in the video, hopefully. And there we go. We are uploading it to the Arduino. It's successful. And now I'm going to go ahead and move over to the Arduino IDE. Again, as I said at the beginning of the video, this is purely so I can use the serial monitor function. And I'm going to do that now. So I'm going to use the serial monitor function. I get my nice welcome display message. It's requesting that I enter an alphanumeric string. And so I'm going to type in hello world, enter. And it's going and outputting that string character by character and displaying it over the LED. And I hope you can see the video that shows the LED blinking, but I'll make sure that I switch over to that as well. I'll just show you the serial monitor first. It is outputting hello. It's a long period of time for the space. And then it's going to go into world. Go ahead and let that run. Now that I'm making this video, I realize I should have had some way to break the application earlier. But now we're here, it is finished outputting hello world, and it has stopped because the code actually clears out to the input string after it has displayed everything. And then it goes ahead and requests another alphanumeric string or the sentinel character. I'm just going to show the sentinel character right here. If I type in that / and hit enter, it's going to give me my goodbye message, and now the application is frozen until I reset something. So I'll go ahead and actually reset it on the Arduino just with the handy dandy reset button. The serial monitor should show again my welcome message. And let's go ahead and do one more check, which is the validity check. So if I enter in a bunch of special characters, my validity check shows a message saying that my string contains non-alphanumeric characters and to try again. So now what I'll do is actually close out my share screen and put the focus on the video to make sure you can see a hello world string get displayed on the LED. So I'll go ahead and stop sharing here. Pin the video of the Arduino LED. I hope this Zoom recording will catch that. I'll go ahead and press enter on hello world. And you can see that the LED is flashing the requisite characters for hello world. And again, it's a little bit of a long screen. Right, so it has completed. And if I share my screen once again to the serial monitor, it is requesting another alphanumeric string from me. And in this case, I've hopefully adequately shown what this system is capable of doing. So I will just end the program